In this video, you will learn how to determine whether a situation represents exponential growth or exponential decay by looking at the function modeling the situation. First, let's talk about exponential growth or decay functions. Exponential growth or decay can be represented using a function in the form f of x equals a times the quantity 1 plus r to the x power, where a is the initial value of the function and must be positive, and r is the rate of growth or decay. For example, if the growth rate is 15%, or 15/100ths in decimal form, the function would have 1 plus 15/100ths in the parentheses. This would simplify to 1 and 15/100ths in the parentheses. For a rate of decay of 2%, or 2/100ths in decimal form, the function would have 1 minus 2/100ths inside the parentheses. This would simplify to 98/100ths in the parentheses. Functions that represent exponential growth have a number greater than 1 raised to the x power. This occurs because the growth rate is added to 1. Functions that represent exponential decay have a number between 0 and 1 raised to the x power. This occurs because the decay rate is subtracted from 1. So, when using a given function to determine if a situation represents exponential decay, look to see what number is being raised to the variable exponent. If an exponential function is written in the form f of x equals a times b to the x power, the function will show exponential growth when b is greater than 1 and the exponential decay when b is between 0 and 1. Let's look at an example. The population of a city is modeled by the function f of x equals 25,642 times 1.05 to the x power. Does this function show that the population of the city is experiencing an exponential growth or an exponential decay? To determine whether this situation represents exponential growth or decay, look at the equation for the function. What value is being raised to the variable exponent? The value 1.05 is being raised to the x power. Since 1.05 is greater than 1, this situation represents exponential growth. Let's look at another situation. The square footage of a yard covered by a specific type of grass over time is modeled by the function f of x equals 285 times 0.95 to the x power. Which statement about this function is correct? A. This function represents decay because the term 0.95 is very close to 1. B. This function represents decay because the term 0.95 is between 0 and 1. C. This function represents growth because the term 0.95 represents a 95% increase. Or D. This function represents growth because the term 0.95 is positive. To determine whether this situation represents exponential growth or decay, look at the equation of the function. What value is being raised to the variable exponent? The value 0.95 is being raised to the x power. Since 0.95 is between 0 and 1, this situation represents exponential decay. Now let's look at the answer choices. You know it is exponential decay, so it has to be choice A or B. The reason you know it is exponential decay is because the value being raised to the variable exponent is between 0 and 1. So the reason you know it is exponential decay is because 0.95 is between 0 and 1. The answer would be B. Now you know more about how to determine whether a situation represents exponential growth or exponential decay by looking at the function modeling the situation. Thanks for watching.